Okay, so the ice cores and the changes in CO2 are directly related to carbon dioxide, carbon cycle, and so on, which is what we are looking at in this section. I get a phone call. I have to stop and take the phone call. So let me do that. Okay, so we come back, and sorry for the interruption. When you are doing work at home or even in the office, you get urgent phone calls that you cannot ignore. So we are moving a little bit away from, let me make sure I'm in the frame here, a little bit away from the carbon cycle itself, but we need to do this. Obviously, Ice-Albedo feedback is a big part of the long-term CO2 variation, and that's why we need to look a little bit more. And again, I should remind the little kids, if you are listening, whatever grade you are, this may be difficult for you to follow, but don't worry, ask somebody. And this is for the older kids. So let's look at a couple of loops of how feedbacks are typically talked about. So here is the melting of ice, sea ice, let's say started by increased greenhouse gases, or by the end of the ice age due to natural causes, changes in orbit and sun's energy and so on. If you melt sea ice, you would lower the albedo because you would expose the ocean and you would become darker naturally, and that would increase the absorbed sunlight, so less of the sunlight is reflected, which means temperatures go up and you get more melting of the ice, and you have this loop going in the same direction. That means whatever started this process is going to get accelerated by the positive feedback. So positive feedback systems typically are unstable, so that's why here once you start melting, it'll go very rapidly. Once you're building, also it is a positive feedback. You keep on building more and more, but it goes slower because albedo increases, CO2 decreases, but air gets drier as it gets colder, and water vapor decreases, so snowfall rates decrease as well. So those are the kind of things that matter. So this is, let's say, the long-term kind of feedback, but this is also happening right now. So if we look at another kind of figure, let's say think about ice-albedo feedback for a runaway freeze, where somehow you created in a loop. You can start anywhere. Okay, so let's say you have a certain level of glacier cover, so the surface is brighter, albedo is higher, so more of the sun's energy is being reflected back to space, which would create a colder surface compared to when the surface is not as bright, and that colder surface would give you more ice cover because it's going to keep losing energy reflecting to space and keep getting colder. So especially over the ocean, you can build more sea ice. Remember, glacier is on land, it builds by compressed snow. Sea ice is actually frozen water, it is on the ocean, or you have lake ice as well, and even the soil can freeze, as we will see later. So that ice cover would then increase the brightness of the surface, cause more energy to be reflected, and cause the cooling again. So this will go into a runaway freeze, means you start it and it keeps going till there is a limit of how much you can freeze. Once you cover the entire planet, for example, you cannot freeze anymore because all the water has been covered by ice. Okay, so that's the way to think about it. Now what's happening now, right now? So this is the polar bear week of 2015. This is from a nice institute which I oops, where did I put the this is from bearinternational.org. So actually it comes from this site that I took. This is from colorado.edu, so that's in CU Boulder or maybe in Fort Collins, United States. So Arctic is the Earth's air conditioner, or at least has been so far and continues to be, because it has a lot of sea ice. So sunlight comes in, lots of bright sea ice, and it's going to get reflected and it can remain cold, except if you make a hole in it and melt sea ice, let's say because of increased greenhouse gases. That's going to reduce the albedo. Look at how bright white this is, and this is darker in a blue color, and depending on the sunlight it can be even more dark, and that's going to absorb sunlight and begin to melt more ice and expand the hole, and soon you will have melting of the ice. And we'll see later on that polar bears, which rely on sea ice for going around, for hunting, for surviving, they are going to have trouble, and they are already having lots of trouble. But as long as the Arctic can remain cold with sea ice and so on, it provides cool air for the rest of the world, especially the northern hemisphere, and ice and snow reflect most of the sun's light and heat back to space rather than absorbing it in the natural climate, or as long as sea ice is there. By protecting the earth from absorbing too much of the sun's heat, Arctic sea ice helps keep the whole planet cool. This is true energy balance, right? But if we start melting it, then you have trouble. So here ice helps reflect some of the sun's heat as you begin to absorb more and more of the sunlight at melted spots. So less sea ice means more heat is absorbed into the ocean. Just as a heart circulates blood and regulates the body's temperature, the ocean controls the world's climate system by circulating heat, moisture, and the nutrients around the planet. We talked about the wind-driven circulation and the thermohaline circulation. We talked about how water takes down heat and greenhouse gases. We didn't talk much about nutrients, but there are nutrients circulating in the water as well in the ocean. Disruptions in the system, such as extra heat, have global impacts and can lead to more frequent and extreme weather events around the world. Now we are introducing a new word here, extreme weather. When it rains normally as you are used to, that's normal rain. When it rains very heavily with strong winds, for example, it's called extreme rain. When temperatures are warm in May, because it's supposed to be warmer than December, that's normal. But if it gets very hot like it is this year, then it's extreme heat. So extreme weather events are bad, with increased trapping of energy because of loss of sea ice and trapping of heat. We get extreme weather. Okay, so as ice melts, less heat from the sun is reflected back to space, and more of it is absorbed by the ocean. So absorbed sunlight and absorbed sunlight and absorbed sunlight, you can see sea ice has disappeared, and here is a polar bear that is in trouble because polar bear needs sea ice to jump around and catch its prey, whether it's seals or fish or whatever else it is eating. So this is not good news. So now we have completed the little introduction to Ice-Albedo feedback, and since it is a very important part of carbon cycle as well, we had to do it. Now we'll come back and look at some carbon cycle numbers again before we close this chapter. Okay, see you in the next chapter.